Close your eyes and travel back, far beyond the history of man, to a time when the world was one. Imagine every mountain, every desert, and every forest you've ever known, all gathered together into a single vast embrace. This was Pangaea, a silent giant resting in a limitless ocean. There were no borders, no divided shores, only the slow, rhythmic breathing of a planet in its youth. A world that moved so slowly, its dance took millions of years to complete. Tonight, we drift with the continents. We will watch the earth tear apart and heal itself in a slow-motion masterpiece. Let the ancient weight of the world ground you and carry you into the deepest of sleeps. Welcome to scientific serenity. Close your eyes and let time stretch, not into minutes or hours, but into millions of years. Let the frantic pace of human life dissolve, and tune your ear to a slower, grander rhythm, the rhythm of the planet itself. Tonight, we travel back not to a year or a century, but to an age when the world map was being redrawn by forces so vast, so patient, they make mountains seem temporary. This is the story of a union, the greatest coming together in Earth's history. This is the story of Pangaea's birth. Our journey begins in the late Paleozoic era, around 335 million years ago. The world we would recognize is gone. The continents we know, North America, Europe, Africa, South America, exist, but they are not where they are today. They are scattered across the globe, separated by ancient, vanished oceans with names like the Reich Ocean and the Paleotethys. They are lonely giants, adrift on a molten sea. Beneath them, in the semi-solid mantle, Earth's engine is turning. Heat from the planet's radioactive heart creates slow, colossal convection currents, rivers of rock flowing over millions of years. These currents are the true movers of the world. They push and pull the brittle, fragmented plates of the crust above. For eons, these forces have been conspiring, nudging the scattered land masses toward a single, inevitable point, a colossal convergence. Picture it from space. The northern continent of Russia, a marriage of what will become North America, Europe, and parts of Asia, is slowly drifting south. The southern supercontinent of Gondwana, holding Africa, South America, Antarctica, Australia, India, and Arabia, is drifting north. Between them lies a shrinking, ancient sea. Their movement is imperceptible, a few centimeters per year, the speed at which your fingernails grow. But over millennia, those centimeters become kilometers. Over millions of years, they become a collision course. The first contact is not a cataclysm, but a gradual embrace. Coastlines of what will become Northwest Africa begin to press against the southeastern shores of ancient North America. This is not a sudden crash, but a slow, relentless press. The crust, under unbelievable pressure, does not break immediately. It folds. It wrinkles. It begins to push upward. This is the beginning of a mountain range that will one day be worn to nubs, but in this moment, it is being born. The Variscan or Appalachian Mountains. Their rise is a slow-motion event, a crumpling of the Earth's skin that takes millions of years to reach its peak. As you imagine this, let the soundscapes settle into your bones. That deep, grinding groan is the sound of continental shelves, thick with sediment, meeting and interleaving like the pages of two giant books being pushed together. The low, tectonic hum is the mantle convection, the deep, driving force behind it all. There is no violence here, only immense, inevitable force. Meanwhile, from the east, the smaller continental fragments that will become parts of southern Europe and other terrains are also being swept into the gathering storm. The Great Tethys Ocean, a vast east-west seaway, begins to close, its oceanic crust diving beneath the advancing continents, melting and fueling volcanoes that punctuate the new, converging shoreline with arcs of fire. This is the prelude, the gathering of the clans. For tens of millions of years, this dance of approach continues. The oceans between the land masses narrow from vast seaways to shallow seas, to inland lagoons, and finally to swampy, low-lying plains where early amphibians crawl and giant dragonflies hum. The world is literally closing in on itself. Finally, around 300 million years ago, the last of the seaways close. The connection is complete. From the fringes of modern-day Mexico to the coasts of Spain, from the heart of Brazil to the western deserts of Africa, there is now unbroken land. Pangaea is born. It is not yet fully consolidated. Its interior is a patchwork of newly sutured mountain chains, vast basins, and remnant shallow seas. But it is one, a single, sprawling, C-shaped supercontinent that stretches from pole to pole. For the first time in hundreds of millions of years, a land animal could, in theory, walk from the South Pole to very near the North Pole without getting its feet wet. The planet has a single giant face. As this new reality solidifies, a profound silence falls over the interior. The roaring winds of vast oceans are now thousands of kilometers away. The world holds its breath. The stage is set for a new kind of Earth, an Earth of extreme continental climates, of vast deserts forming in the rain shadow of the new mountains, of unique evolutionary pathways opening in the unprecedented connectedness of its lands. But for now, in this first, quiet moment of union, there is just the deep, grinding peace of completion. The great convergence has reached its climax. The scattered pieces are one. We will explore what life was like in this new, united world in our next chapter. But for now, rest in the immense, slow-motion power of that creation. Feel the weight of the mountains rising. Hear the groan of the closing ocean basins. This is the planet dreaming of unity. This is the first deep breath of a supercontinent. With Pangaea now assembled, we must shift our perspective from the aerial view of colliding continents to the ground-level reality of this new world. What was it like to stand on this newborn supercontinent in its earliest days? The answer lies not in vibrant life or lush forests. Those will come, but in a landscape of raw, geological adolescence, a world breathing its first, unified breath. The interior of Pangaea, far from any ocean, was a place of profound climatic extremes, with no large bodies of water to moderate temperature. The heart of the supercontinent experienced brutal swings. Scorching days gave way to freezing nights. But more significantly, the newly risen mountain ranges, the colossal spine of the Appalachian's Variscan chain running along the equator, and the Ural Mountains beginning to form in the north, created a massive rain shadow. Moisture-laden winds from the shrinking Paleotethys Ocean in the east and the Panthalassic Ocean, the global ocean that surrounded Pangaea, would rise to cross these mountains, dump their rain, and descend as dry, arid air. Thus, in the very heart of the united world, a mega-monsoon climate began to establish itself, but its most iconic feature would be the deserts. Vast, sweeping ergs of sand, the ancestors of the Sahara, but on a continental scale, began to form. These were not deserts of rolling dunes as we know them today, but immense, silent, sun-blasted basins, where the only sound was the whisper of shifting grains over bedrock, a sound like a billion tiny sighs. This is where our wind sound originates, a constant, gentle, yet immense flow of air over thousands of kilometers of open, barren land. Yet, Pangaea was not all desert. Along the coasts, particularly in the humid equatorial regions and in the southern reaches of Gondwana, conditions were different. Here, in the constant warmth and moisture, a revolutionary form of plant life was taking hold, the first giant lycophyte forests. These were not forests of flowering trees, but of strange, towering relatives of modern club mosses and horsetails. Lepidodendron and sigillaria rose like great, scaled pillars, 30 to 50 meters high, with a canopy of simple, grass-like leaves. The forest floor was a spongy mat of decaying vegetation and giant mosses. The sound here was a world away from the desert's sigh. It was a damp, quiet world. The air would have been still, heavy with moisture and the smell of rot and growth. The soundscape would be one of subtle, organic processes, the soft drip of moisture from the canopy, the faint creak of a giant lycophyte trunk in a rare breeze, the munching of early, giant arthropods like Arthropleura, a millipede the size of a car, moving through the undergrowth. It was a quiet, primeval, and deeply alien serenity. Beneath both desert and forest, the earth itself was still settling. The immense weight of the new supercontinent had a profound effect on the planet's crust. Geologists call this supercontinent insulation. With so much land concentrated in one area, heat from Earth's mantle became trapped beneath the thick, continental crust. This led to a gradual, global warming from below. The lithosphere, the rigid outer shell, began to weaken over the heart of Pangaea. Deep, massive plumes of superheated mantle material, called superplumes, began to gather strength beneath it. This thermal buildup was the seed of Pangaea's eventual destruction, but for now, it was just a deep, restless warmth. On the surface, it manifested as widespread, gentle volcanism and the slow uplift of broad, dome-like regions. The continent was not static. It was slowly breathing, swelling with the planet's inner heat. This is the central character of Pangaea's birth. It was a world of contrasts and connections. Extreme desert connected to swampy forest. Freezing polar night connected to baking equatorial day. For the first time, flora and fauna could spread across these connected landscapes, leading to a grand mixing of evolutionary lineages. But it was also a world of immense isolation in its interior, an isolation of distance and climate. The soundscape of the young supercontinent was thus a tapestry of these contrasts. In one moment of our meditative journey, we hear the endless, dry wind of the interior. In the next, we are transported to a silent, dripping rainforest where time feels even slower, measured in the growth of a trunk over a century. And through it all, underpinning everything, is that deep, tectonic hum, the sound of the planetary engine. It is a reminder that this unity, this magnificent union of all lands, is not a permanent state. It is a phase in Earth's endless, slow dance. The heat is building beneath. The mantle is stirring. The very forces that created Pangaea are preparing to tear it apart. But that rift is tens of millions of years in the future. For now, in this chapter, we sit with the completed puzzle. We feel the scale of a world made whole. We listen to its first simple, elemental sounds: wind, water, rock, and deep earth. It is a symphony of geography on a scale never heard before or since. As we settle into the reality of this newborn Pangaea, we must confront a paradox that lies at the heart of all supercontinents. Their greatest strength contains the seeds of their own destruction. Pangaea was unified, massive, and dominant, but in its very unity, it created a new set of planetary rules, rules that would ultimately lead to its fragmentation. This final part of our chapter explores the legacy of the birth, not just the mountains and deserts, but the deeper geophysical imprint Pangaea left on the Earth itself. For planet is not just a collection of surfaces. It is a dynamic system of energy flow. And Pangaea, by rearranging the continents, rearranged the planet's energy budget. First, the climate. With one giant landmass straddling the equator and extending to the poles, ocean currents, the great planetary conveyor belts of heat, were dramatically altered. The global ocean, Pangaea, could now circulate in a single, uninterrupted loop around the supercontinent. This circumglobal current likely contributed to the climate extremes, ferrying warm water to high latitudes, but also isolating the interior from moisture. The Earth's climate system became, in a sense, simpler in its geometry, but more extreme in its expression. Second life. The formation of Pangaea was both a great unifier and a great divider for evolution. On one hand, It created a cosmopolitan fauna and flora. Land animals and plants could now spread across previously impossible distances, leading to a mixing of species and a decrease in regional uniqueness. On the other hand, the harsh interior deserts and mountain ranges became formidable barriers, creating isolated pockets where evolution could experiment in new directions. This duality, connection and isolation, would set the stage for one of the greatest diversifications of life in Earth's history, still millions of years in the future. But the most significant legacy was hidden from view in the mantle. The concentration of all continental crust in one area acted like a thick, insulating blanket on the Earth's surface. The heat rising from the planet's interior, which normally escapes through the thin oceanic crust scattered across the globe, was now trapped. This thermal insulation caused the mantle beneath Pangaea to grow progressively hotter. Imagine a pot on a low flame with a lid. The heat builds. Convection in the mantle, which drives plate tectonics, became more vigorous beneath the supercontinent. Massive, sprawling upwellings of superheated rock, superplumes, began to form at the core mantle boundary. They did not rise swiftly. Their ascent is a story of millions of years, but their destiny was clear: to reach the base of the lithosphere, the rigid outer shell, and weaken it from below. This is the source of that deep, singular crack we heard. It is not the sound of Pangaea breaking. That will come later, with a symphony of such cracks. It is the sound of the lithosphere, under this growing thermal stress, developing its first, deep-seated line of weakness, a future zone of divergence, a seed of separation. It is the planet's deep memory already recording the end of this united era, even at the moment of its greatest unity. Thus, the birth of Pangaea was not a clean beginning. It was the climax of one cycle, the cycle of continental convergence, and the unconscious, inevitable start of the next, the cycle of continental rifting. In the silent, stretched-out time of geology, birth and death are not separate events. They are two sides of the same slow, turning wheel. As our first chapter closes, let your minds take a final view of this united world. See it from space, a single, rugged, C-shaped continent of browns, reds, and greens against the boundless blue of Panthalassa. Feel its immensity, its quiet, arrogant permanence. But know, in the way you might sense the first, faint chill of autumn on a perfect summer day, that this permanence is an illusion. The heat is building beneath. The mantle is stirring. The dance is about to change tempo. The story of Pangaea is not a story of a static entity. It is a story of a process, the process of Earth balancing and rebalancing its own energy, its own mass, its own identity over deep, deep time. We have witnessed the gathering. Next, we will witness the flourishing of life in this strange, connected world, in the age of giant forests and eternal deserts. But for now, let the sounds of this newborn supercontinent settle into a gentle, resonant peace. The wind, the deep hum, the memory of the crack, all blend into a single, low, soothing drone. It is the sound of the planet holding a note that will be held for tens of millions of years. Welcome back to the world made whole. Pangaea now exists, a finished puzzle of continents. But to be united is not to be uniform. In this chapter, we leave the aerial view of colliding plates and descend into the soul of the supercontinent itself. We will explore its two most defining, contrasting faces, the eternal deserts at its scorching heart, and the giant forests that clung to its humid fringes. This is not a tale of two planets, but of one planet breathing in two utterly different rhythms. Let us begin in the silence of the center. Journey inland from any coast for thousands of kilometers. The ground turns rocky, then sandy. The moisture in the air vanishes. You have reached the Pangaean mega-monsoon desert, one of the most extensive arid regions in Earth's history. Here, in the rain shadow of the colossal central Pangaean mountains, the air is dry enough to crack stone. Rain, if it comes at all, arrives in violent, sporadic downpours that evaporate almost before touching the ground, leaving behind cracked mudflats. This desert is not a sea of dunes like the Sahara. It is a hamada of vast, flat, rocky plains strewn with boulders and gravel, polished smooth by the endless, gentle abrasion of wind-blown sand. The sun is a merciless, white disk in a pale, dust-hazed sky. The heat during the day is intense, radiating from the dark rock. At night, with no moisture or cloud cover to trap heat, the temperature plummets, and the stars blaze with a cold, sharp clarity unseen in our modern, humid world. The sound here is the sound of absence. The wind is constant, but it is a dry, empty wind with nothing to rustle, nothing to howl against. Its sound is a soft, deep sigh, a bass note to the desert's existence. Occasionally, a stronger gust will lift a sheet of fine sand, creating a momentary, whispering shush that fades as quickly as it arises. At night, the rocks themselves contract from the cold, emitting faint, sharp pings and cracks, the desert talking to the stars in a language of thermal stress. Life here is scarce, specialized, and hidden. Hardscrabble plants like primitive conifers and cycads might cluster in rare, protected gullies where water occasionally pools. Small, tough reptiles and early synapsids, the ancestors of mammals, emerge at dawn and dusk, their scales and hides adapted to retain moisture. Their movements are slow, deliberate, conserving energy. The desert enforces economy of motion, of life, of sound. It is a landscape of profound, minimalist peace, where time is measured not in growth, but in erosion, the slow, grain by grain wearing down of mountains into sand. Now let the soundscape shift. Let that dry wind recede, replaced by a thick, palpable stillness. We have traveled thousands of kilometers to the equatorial coasts, or to the temperate southern reaches of Gondwana. Here, the air is heavy with moisture, warm and still. We are under the canopy of the Carboniferous rainforest. This is not a forest of birdsong and chattering monkeys. This is a silent, primeval world. The trees are lycophytes, giant relatives of modern club mosses. Lepidodendron rises like a scale column 40 meters high, its trunk diamond-patterned, its crown a spray of simple, grass-like leaves. Sigillaria stands beside it, its trunk marked with vertical rows of leaf scars. There are no flowers, no fruit. The only color is various shades of green, brown, and the muted white of giant fungi that decompose the fallen giants. The forest floor is a spongy, unstable mattress of decaying plant matter, peat, and giant mosses. It is dark, for the dense canopy allows little light to penetrate. The air smells of damp earth, rotting vegetation, and the faint, sweet scent of spores. This is a world ruled by plants and decomposers. The animals here are arthropods, giant dragonflies, Meganeura, with wingspans over 1/2 meter that glide silently between the trunks, and enormous millipedes, Arthropleura, longer than a human, moving with a slow, deliberate rustle through the leaf litter. The soundscape here is one of subtle process, not of activity. The dominant sound is the occasional, heavy plop of a water droplet falling from the canopy high above, hitting a leaf or the soft ground below. It is a sound that echoes in the stillness. There is the faint, continuous crackle of the forest itself, the sound of growing, of settling, of microscopic decay. A branch, after a lifetime of centuries, might finally give way with a deep, muffled snap and a soft crash as it descends through layers of vegetation to the forest floor. It is a sound that might happen once a week. This is the duality of Pangaea, the expansive, empty exhale of the desert, and the dense, introverted inhale of the rainforest. One is defined by the movement of air over rock, the other by the stillness of air among plants. One is a canvas for the sky. The other is a world that creates its own sky of leaves. And between these two extremes, along river valleys and in shifting zones of climate, life navigated a precarious balance. But for now, as this chapter opens, we simply bear witness to the two purest states of the supercontinental climate, two kinds of silence, two forms of deep geological peace. Between these two titanic realms, the desert's exhale and the forest's inhale, existed the true theater of life on Pangaea, the transition zones. Here, in the seasonally wet river valleys that snaked from the mountains to the coasts, in the shifting margins of the mega-monsoon belt, the supercontinent story was written not in stone or silence, but in adaptation and struggle. This is where the legacy of Pangaea's unity was etched into the very DNA of terrestrial life. Imagine a broad, shallow river valley cutting through the fringes of the desert. For much of the year, it is a dry, sandy wash. But when the unpredictable, violent monsoon rains finally arrive in the distant highlands, a wall of water, a flash flood of unimaginable scale, roars down the channel. It carves the land, deposits fresh sediment, and creates temporary oases of lush vegetation. This cycle of feast and famine, of drowning and desiccation, shaped the evolution of the period's amphibians and early reptiles. Life here had to be opportunistic, resilient, and able to exploit brief windows of abundance. The sound here is one of sudden, violent change followed by long, parching silence. The distant roar of an approaching flood, then the chatter of receding water, then the crack of drying mud under a relentless sun. Conversely, at the inland edges of the rainforests, where the humidity began to wane, life faced a different challenge: encroaching aridity. Forests gave way to open woodlands of more drought-resistant gymnosperms, like early conifers and ginkgos. Here, the soundscape was a mix: the rustle of smaller, tougher leaves in a breeze that carried a hint of dryness, the calls of different insects, the movement of animals adapted to a more open, sun-dappled world. It was a borderland, an ecotone where the two great silences of Pangaea whispered to each other through the medium of life. But the most profound story is written in the coal. The vast, stagnant swamps of the rainforests, where giant lycophytes lived, died, and fell into oxygen-poor water, did not fully decompose. Layer upon layer of this organic matter accumulated over millions of years, was buried, and under heat and pressure, transformed into the great carboniferous coal seams that power our industrial world today. That gentle forest drip and crackle we hear is, in a very real sense, the sound of ancient sunlight being stored as chemical energy. Each drop of water hitting the peat is a tick of the geological clock, burying carbon that would one day be released back into an atmosphere it helped shape. The forest silence was an active, world-changing silence. The desert, for its part, was writing a different record. The endless wind was not just moving sand. It was sorting minerals, creating vast ergs, sand seas, and depositing layers of perfectly sorted sand that would one day become the sweeping, cross-bedded sandstone cliffs we marvel at in canyons. The desert's sigh was a sculptor's breath, patiently carving and piling grains into monuments of time. Both environments, in their extremity, were engines of evolutionary pressure. The desert selected for water conservation, heat tolerance, and burrowing. The dense, competitive rainforest selected for height, efficient spore dispersal, and strategies to thrive in low light. Pangaea, by creating such vast, uninterrupted stretches of these environments, allowed these evolutionary experiments to run on a continental scale. Species could spread, specialize, and diversify across thousands of miles without encountering a barrier like an ocean. This led to a unique biogeographic homogeneity. Similar creatures and plants could be found from one side of the supercontinent to the other, a unity of life mirroring the unity of land. Yet, beneath this surface of life and silence, the planetary engine continued its work. That deep geothermal pulse we sense is the heat building under Pangaea's insulating blanket. It is the same heat that drives the convection cells moving the plates, that fuels the volcanoes on the margins, and that will eventually become the force of rupture. Even here, in the timeless stillness of the desert and the ancient, dripping cathedral of the forest, the countdown to the supercontinent's dissolution has already begun. The very environments we marvel at are, in the grandest scale, temporary expressions of a planetary configuration that is inherently unstable. As we hold both soundscapes in our mind, the wind and the drip, we begin to perceive Pangaea not as a static picture, but as a dynamic system in slow equilibrium. The deserts and forests are in balance with the atmosphere, the mountains, the planet's rotation. It is a balance of immense power and profound fragility. A slight shift in Earth's orbit, a gradual change in solar output, or the relentless buildup of the mantle's heat, and this entire beautiful, silent world will begin to transform. But for now, in this long, golden afternoon of the Carboniferous, the giant forests breathe in, and the eternal deserts breathe out. And in that breath is the peace of a world at the height of its united power. As our journey through Pangaea's contrasting heart reaches its conclusion, we must step back and behold the supercontinent not as a collection of environments, but as a single, living entity. The desert is its dry, weathered skin, absorbing the sun's relentless gaze. The rainforests are its dense, moist lungs, breathing in carbon and exhaling oxygen in a slow, planetary rhythm. The mountains are its bones, still warm from the violence of their birth, and the vast, hidden mantle below is its restless, warming blood. This unity of purpose and form is the true wonder of Pangaea. For perhaps the first and only time in Earth's history, the continental biosphere was a continuous, interconnected whole. A spore released from a giant lycophyte in what is now China could, in theory, drift on the wind to settle and grow in what is now Texas. A small, hardy reptile could, over countless generations, spread its lineage from the fringes of the South Pole to the arid interior, adapting mile by mile to the changing conditions. There were no deep ocean trenches to cross, no isolated continents where evolution could spin off into radically different directions without interference. Pangaea was a grand, evolutionary arena, and the fights for survival, the adaptations to extreme climates, played out on the greatest possible stage. But this very unity contained a paradox that brings us to a profound, almost philosophical, reflection on deep time. The forests, in their magnificent, silent productivity, were busily removing carbon dioxide from the atmosphere and burying it as coal. This gradual drawdown of a potent greenhouse gas, over millions of years, is believed to have contributed to a global cooling trend that would later help usher in an ice age. The deserts, by reflecting sunlight back into space with their bright sands, also contributed to cooling. In striving to thrive, the life and landscapes of Pangaea were unconsciously altering the very global climate that sustained them. They were sowing the seeds of their own transformation. This is the gentle, inevitable tragedy written into the geology of our planet. Stability is always a prelude to change. The perfect adaptation contains the germ of future obsolescence. The supercontinent, the ultimate expression of terrestrial stability, was, through the very processes it fostered, preparing the planet for a shift. The climate was cooling, the mantle was heating, and at the boundaries between these two great realms, between the desert's exhale and the forest's inhale, the first faint signals of the coming storm were perhaps already perceptible. Did a particularly long drought cause the rainforest to retreat, exposing peaty soils to the air and allowing stored carbon to leak back? Did a period of intense volcanic activity on the periphery, driven by that building mantle heat, pump enough ash and gas into the atmosphere to briefly chill the planet, stressing the great forests? We cannot know the precise triggers, but geology teaches us that systems at equilibrium for too long accumulate the potential for profound change. Pangaea, in its majestic, balanced maturity, was a coiled spring. As we prepare to leave this long, green and golden afternoon of Earth's history, let the blended soundscape be your guide into a state of deep temporal perspective. The sound is no longer of a desert or a forest, but of Pangaea itself. It is the sound of a planet breathing as one organism. It is a sound of immense peace. But if you listen at the very edge of perception, within that deep geothermal pulse, you can hear the first, almost melodic strain, the subtlest suggestion that this single, held note cannot last forever. For the cycle must turn. The heat beneath must find a release. The continents, having gathered, must now begin their long, slow waltz apart. The great forests will falter, their coal-seamed tombs becoming their legacy. The deserts will be flooded by new seas. The map will be redrawn. But that is the story of the next chapter, the story of the rift. For now, as this chapter closes, rest in the profound, unified silence of the supercontinent. It is a silence that lasted for tens of millions of years, a silence in which giant dragonflies glided, millipedes longer than a man navigated the gloom, and the wind polished stones smooth in a desert larger than any seen before or since. It is a silence that is the true background hum of deep time, a lullaby for the planet itself. We have felt the deep peace of a united world. We have breathed with its forests and felt the sigh of its deserts. But all unities, no matter how vast or enduring, carry within them the whispers of their own end. The story we turn to now is not one of collision, but of separation. Not of birth, but of a slow, inevitable divorce. This is the story of the Great Rift, the moment when Pangaea, the world continent, began to dream of becoming many. For nearly 100 million years, Pangaea had been the solitary face of the earth, but the forces that had assembled it had never ceased. The mantle's convection currents still flowed, and the heat trapped beneath the supercontinent's thick, insulating lid had been building. That deep geothermal pulse we've been sensing was the heartbeat of a growing pressure. Deep below, in the searing heat near Earth's core, one or more superplumes, mushrooming upwellings of superheated rock, had risen through the mantle. They now pressed, with the patience of epochs, against the underside of Pangaea's lithosphere, the planet's rigid outer shell. The first signs were not dramatic. There were no earthquakes that would shatter cities, for there were no cities. There were no volcanoes that would blacken skies. Not yet. The first sign was a broad, gentle uplift across a swath of land that would one day become the central Atlantic. The Earth's crust began to swell. Over millions of years, a vast, domed region, thousands of kilometers across, rose like a giant blister. Rivers that had flowed to the coast for eons found their courses disrupted, spilling into vast, shallow interior basins. The land itself was stretching, subtly, imperceptibly. And then, the stretching surpassed the rock's ability to stretch. The lithosphere, under tension, began to thin. From below, the heat of the superplume softened it. From above, the sheer weight of the uplifted dome pulled it apart. It was a slow-motion torture of stone, and in its thinnest, weakest zone, a line that ran roughly where the modern mid-Atlantic ridge lies today. It began to fail. This is the source of that low, tearing sound. It is not a single event, but a continuous process happening across hundreds of thousands of years. It is the sound of continental crust, dozens of kilometers thick, being pulled so taut that it begins to develop a network of microscopic fractures. These fractures grow, connect, and deepen. They are the first rift valleys of the New World. Imagine standing on this land. You would notice nothing in your lifetime, nor in 1,000 lifetimes. The ground is not shaking, but if you could speed time, you would see a colossal, linear scar beginning to form, a gash in the supercontinent. The center of this scar begins to sink, creating a long, narrow depression. On either side, great fault blocks of crust tilt upward, forming the first rugged shoulders of the rift. This is not the clean break of a snapped twig. It is the messy, gradual tearing of a tough, fibrous material. Within this sinking rift valley, the environment transforms. As the crust thins, the underlying mantle rises closer to the surface. Its heat begins to bake the rocks, metamorphosing them. Magma, generated from the decompressing mantle rock, starts to gather in pockets. The first volcanism begins, not explosive peaks, but fissure eruptions, where lava quietly wells up from long cracks in the valley floor, spreading out in thin, black sheets that cool into basalt. The soundscape here adds a new layer. The soft, distant fizz and gurgle of magma degassing, the gentle hiss of hot rock meeting air or water, and the occasional, deep thud of a large fault block settling. This is the birth of the Central Atlantic Magmatic Province, though it will be millions of years before there is an Atlantic to be central to. It is a period of profound geological unrest, yet it is so slow, so vast, that to any creature living then, it would have been indistinguishable from stability. The true rupture, the moment when seawater would finally rush in, was still millions of years in the future. For now, Pangaea was not breaking. It was being prepared to break. A surgical incision was being made, slowly, by the planet's own internal heat. As you listen to the sounds of this deep, tectonic tension, the tearing, the rising hum, the subterranean gurgle, understand that you are hearing the prelude to the most important map-changing event since the supercontinent formed. You are hearing the first notes of a new ocean's overture. The rift is no longer a secret whispered in the rock. It is now a defining feature of the landscape, a continental wound hundreds of kilometers long and dozens wide. What began as subtle stretching has matured into a full-fledged divergent boundary, a place where the earth actively pulls itself apart. We are now witnessing the mechanics of continental breakup in all its slow, magnificent violence. Picture the Rift Valley from above. It is not a clean, vertical crack. It is a complex, down-drop trench, its floor a patchwork of tilted crustal blocks, volcanic plains, and shallow, salty lakes that form in the lowest depressions. On either side, the fault scarps, the uplifted shoulders of the rift, rise like somber, rocky walls. These are the birthplaces of future coastlines. The land that will one day be New Jersey and Morocco are staring at each other across a gulf that is, at this moment, only an arid, rocky valley. Within this valley, the volcanic activity intensifies. The thinning crust is now so attenuated that magma from the upwelling mantle can reach the surface with greater ease. Fissure eruptions become commonplace. Imagine not a single volcano, but a crack in the ground miles long that suddenly glows with a hellish red light. Silently, for sound does not carry well in these narratives, lava floods out, not in explosive bursts, but in vast, relentless rivers that fill the valley floor, layer upon layer, building up a plateau of basalt. When these flows meet the salty lakes, they explode in clouds of steam, adding a violent, hissing punctuation to the slow narrative. The climate within the rift is extreme. Sheltered by the high walls, it becomes a hyper-arid basin, even as the surrounding uplands may still receive rain. Dust storms whip along its length. The lakes that form are often hypersaline, like a prehistoric Dead Sea, the shores crusted with white minerals. Life here, what little can survive, is hardy and strange. Microbial mats, salt-tolerant plants, and animals that come to the precarious water's edge to drink. But the most profound transformation is not on the surface, it is below. As the crust continues to thin, a point of no return is approached. The continental crust, which is thick and buoyant, is being pulled so thin that it is replaced by something new, oceanic crust. This is the pivotal moment, when the stretching finally tears completely through the continental lithosphere. The hot mantle rock beneath is exposed to the much lower pressure at the surface. It undergoes decompression, melting on a massive scale. This molten rock rises, cools, and solidifies into a new kind of crust, denser, thinner, and basaltic. This is the birth of a mid-ocean ridge, though there is no ocean yet. A linear volcanic mountain range begins to form in the middle of the Rift Valley. It is a submarine volcano chain rising in a desert. Magma wells up along this line, solidifies, and is immediately pulled apart by the ongoing tectonic forces, making room for more magma. This process, seafloor spreading, has begun, but for now, it is happening in an empty, dry rift. The new oceanic crust is forming a narrow, nascent seaway floor that is slowly, inexorably, pushing the two continental halves apart. The soundscape here deepens with this new phase. The tearing is now accompanied by the deep, resonant thrum of creation, the sound of new planetary crust being forged. It is a low-frequency vibration, the sound of billions of tons of basalt crystallizing from liquid fire. The sigh of the widening rift is now a constant, monumental groan. And if you listen very closely, beneath all this, you might hear the first, ghostly suggestion of water, not the sound of waves, but the almost imperceptible, high-pressure seep of groundwater finding its way into the deepest, hottest fractures, flashing instantly to steam. The two halves of Pangaea are no longer just separating. They are now different entities geologically. One side is the future Africa, the other the future Americas. They are embarked on separate tectonic plates, each now carried by the conveyor belt of the mantle's convection currents. Their divorce is legally, geologically, finalized. The marriage of continents is over. Yet, the world at large remains largely unaware. The dinosaurs, who now rule the land in the Jurassic period, roam forests thousands of kilometers away from this scar. Their world is still one of a connected supercontinent, though the map has a new, growing flaw in its center. The true global revolution, the moment when the rift becomes an ocean, awaits one final element, a connection to the global sea. And that connection is coming. For the Rift Valley, now below sea level in many sections and linked to the vast Panthalassic Ocean through a complex network of shallow seas and straits, is about to receive a visitor that will change everything, and whose sound will drown out all others, the ocean itself. The breach has been made. The Rift Valley, deepened by millions of years of stretching and sinking, has finally fallen below the global sea level. Somewhere at a narrow point, perhaps a collapsed segment of the rift shoulder, or a strait opened by further faulting, the waters of the vast, global Panthalassic Ocean find their way in. What follows is one of the most awe-inspiring events in Earth's history, yet it happens with a slow-motion grandeur that no eye could witness. It is not a single, catastrophic flood, but a geological inundation. Seawater pours into the lowermost parts of the rift system, following the dry, volcanic topography. It fills the hypersaline lakes, drowning them instantly. It floods the vast basaltic plains, turning black rock into shallow seabed. It climbs the slopes of the new mid-ocean ridge, submerging the volcanic peaks that were erupting in a desert just epochs before. The sound of this invasion is the true birth cry of the Atlantic Ocean, or rather, its embryonic predecessor, sometimes called the Central Atlantic Seaway. That deep, hydraulic roar is the sound of a planet replumbing itself. It is the sound of a continent being cleaved not just by rock, but by water. The once isolated Rift Valley becomes a narrow, salty, and incredibly active marine corridor. With the ocean comes a sudden and dramatic change in the rift's personality. The hyper-arid desert valley is gone, replaced by a warm, shallow, tropical sea. Sunlight, once beating mercilessly on black lava and salt flats, now filters through turquoise water onto a bizarre landscape. Drowned fault scarps become submarine cliffs, volcanic peaks become seamounts and islands, and the new mid-ocean ridge becomes a submerged, lava-spewing mountain range, the first stretch of the mid-Atlantic ridge. The volcanic activity doesn't cease. It transforms. Instead of fissure eruptions steaming in dry air, we now have submarine volcanism. Lava erupts into water, instantly quenching into pillow-shaped forms, pillow basalt, with a sharp, hissing crackle and the smell of sulfur. Hydrothermal vents, the famous black smokers, crack open on the seafloor, spewing superheated, mineral-rich water that supports strange, chemosynthetic ecosystems, the first life to colonize this brand new piece of the world. The soundscape evolves once more. The roar of the flooding settles into the eternal background murmur of ocean currents, a deep, watery sigh. Overlaying this are the new sounds of this young ocean, the hiss-crackle-pop of submarine volcanism, the low rumble of underwater landslides as the new, unstable slopes adjust, and the haunting, metallic chiming of mineral chimneys growing at hydrothermal vents. It is a soundscape both alien and deeply familiar, the sound of Earth doing what it does best, creating new environments with relentless energy. And what of the two continents? They are now truly adrift. The injection of the ocean is the final wedge. The new oceanic crust forming at the mid-ocean ridge acts as a conveyor belt, continuously pushing the continental plates of Laurasia to the north and west, and Gondwana to the south and east, farther apart. The divorce is not only legal but physical. The distance between them widens at the pace of a growing fingernail, a few centimeters per year, but multiplied by millions of years, it becomes an unbridgeable gulf. The world map is irrevocably altered. Pangaea is dead. In its place is a world with a growing wound of ocean in its heart. The age of isolated supercontinent is over. The age of separated, drifting continents, the age that leads to our modern world, has begun. As we listen to the sounds of this newborn ocean, we should recognize a profound symmetry. The forces that tore Pangaea apart, the heat from the mantle, the convection currents, are the very same forces that now drive the creation of the new oceanic crust at the ridge. Destruction and creation are two sides of the same coin, struck in the forge of the planet's interior. The rift was an ending, But the ocean is a beginning. It is a beginning of new currents, new climates, new evolutionary pathways isolated on separate lands, and new depths to be explored. Our journey through the Great Rift is complete. We have witnessed the slow tension, the violent thinning, and the final watery divorce. We now leave this young, churning seaway behind, its sounds fading into the geological background. But the drifting giants it set in motion have adventures of their own. Their journeys, the epic, lonely voyages of entire continents across the globe, will shape the next chapter of our planet's story. The divorce is final. Pangaea is a memory, its heart now a growing seaway. The Great Rift has set the pieces in motion, and now we watch as those pieces, these drifting giants of stone, embark on their own epic odysseys. This chapter is not about collision or rupture, but about journey. The slow, lonely, magnificent journeys of continents across the face of the earth. With the Central Atlantic Seaway now a permanent feature, the two primary fragments of Pangaea, Laurasia in the north and Gondwana in the south, begin their separate lives. But Gondwana itself is not a single passenger. It is a continent containing continents, a family soon to be scattered by the same tectonic forces that broke the supercontinent. Our story follows several of these giant travelers on their paths, each moving at the speed of a growing fingernail, each destined to reshape the world. First, let us follow the loneliest journey, Antarctica's slow march to the bottom of the world. In the warm, early Jurassic, Antarctica was not a frozen wasteland. It was part of Gondwana's temperate forests, connected to South America, Australia, and Africa. But as the Atlantic widened, the forces acting on Gondwana began to pull it apart from within. A new rift system developed between Antarctica and Australia, and another between Antarctica and the combined South America/Africa. Slowly, agonizingly slowly, Antarctica began to rotate and drift southward. Picture it. A continent the size of Europe and China combined, detaching from its neighbors and embarking on a solo voyage toward the South Pole. For tens of millions of years, it traveled through temperate and then cool latitudes. Its forests of ferns and conifers gradually gave way to colder adapted flora. Its journey was one of increasing isolation and cooling climate, a long, quiet farewell to the green world. The sound of Antarctica's drift is the sound of lonely majesty. That deep, slow creaking is the sound of its continental plate, thousands of kilometers across, pivoting and translating on the sphere of the earth. The wind is the chill, polar wind that begins to whisper across its rising highlands. There's no sound of life to mask it, just the continent and the elements, moving toward an icy destiny. Now, turn our gaze to a journey of fiery collision, India's frantic race north. Unlike the stately drift of Antarctica, India's story is one of startling speed and ultimate impact. Initially a large island fragment attached to eastern Gondwana, India broke away as the Indian Ocean began to open. But it didn't just drift, it sprinted. propelled by a particularly fast-spreading ridge behind it, and perhaps pulled by the subduction of ocean floor ahead of it. India moved northward at a blistering pace, for a continent, up to 20 centimeters per year. It was a geological bullet. For nearly 100 million years, India traversed the ancient Tethys Ocean, a lone continental arc carrying unique species, heading inexorably toward the underbelly of Asia. Its journey was over open ocean, so its soundscape was that of a silent voyager. The deep creak of its motion, the whisper of the ocean winds over its low-lying landscapes, the occasional rumble of volcanoes erupting as its leading edge began to crumple against the approaching Asian plate. It was a continent with a destination, and that destination was a collision of unimaginable scale. And what of Africa? Its story is one of hesitant rotation and internal rupture. As the Atlantic opened to its west, Africa rotated clockwise, grinding against Europe in the north, raising the Alps' earliest ancestors, and most dramatically, beginning to tear itself apart from within. The same rift forces that broke Pangaea now threatened Africa itself. A massive domal uplift rose in its east, heated by a superplume from below, the African superswell. And in the crest of that dome, a new continental rift began to form, the East African Rift Valley. Africa, the heart of old Gondwana, was dreaming of dividing into two pieces, creating a new ocean in a future tens of millions of years away. The sound here is one of tectonic fatigue and rebirth, the deep groaning of the continent bending, the crisp cracking of the rift valley forming, the sigh of lakes filling the new depressions. These are the opening movements of the drifting giants. Each continent, a passive rider on its tectonic plate, is nevertheless an active shaper of global climate, ocean currents, and evolution through its mere position and motion. Their journeys are the slowest odysseys imaginable, written in rock and fossil, felt in the changing breeze over millions of years. As you listen to the deep creak of their motion, understand that you are hearing the engine of Earth's dynamism. This is how the planet reinvents its face. This is how it distributes heat, cycles carbon, and stirs the cauldron of life. The age of the static supercontinent is over. The age of the wandering world has begun. As our drifting giants continue their journeys, we must zoom in from the grand orbital paths to the ground-level consequences of their motion. For a continent's journey is not a smooth glide. It is a saga written in mountain ranges, vanished seas, and transformed ecosystems. The map is not just changing. It is being crumpled, stretched, and rewritten with geological force. Let us witness the climax of India's frantic sprint. After 100 million years of lonely travel across the Tethys Ocean, its northern shores finally approach the southern margin of Asia. There is no ocean crust left to consume. It is continent against continent. The collision begins not with a single, catastrophic impact, but with a slow, relentless crush. India, a continent of relatively light, buoyant granite crust, cannot be subducted easily beneath the equally buoyant crust of Asia. Instead, it begins to plow into it. The leading edge of India crumples, like the hood of a car in a slow-motion crash. Vast slabs of rock are thrust upward, one over another, in a process called thrust faulting. The sedimentary layers that had accumulated on the Tethys seafloor and the ancient rocks of India itself are stacked, folded, and lifted toward the sky. This is the birth of the Himalayas. Their rise is not a single event, but an ongoing process that started around 50 million years ago and continues today. Imagine the sound of this creation, a deep, guttural roar of compression, the sound of a planet shrugging its shoulders. It is not the sharp crack of an earthquake, but a sustained, tectonic growl that lasts for millions of years. Between this growl, you hear the crunch and grind of rock against rock, the tinkle of shattering surface stones and constant landslides, and the roar of rivers cutting ever deeper gorges as the mountains rise faster than erosion can wear them down. It is the sound of the world's greatest mountain range being forged in real time. While India collides, South America and Africa, once intimate neighbors, are now separated by a growing Atlantic. Their journey is one of increasing isolation. As they drift apart, their coastlines, which once fit together like puzzle pieces, begin to evolve separately. The unique species that lived on their connected landmass are now separated by an ever-widening ocean. Evolution begins to take them down different paths. This is the sound of biological divorce, a deep, silent separation underpinned by the gentle, watery sigh of the expanding ocean. The wind that blows over the coasts of Brazil is no longer the same wind that blows over Namibia. They have become strangers. Australia, finally breaking free from Antarctica around 45 million years ago, begins its own solo drift northward. As it moves, it leaves behind the cool, moist climate of the southern high latitudes and journeys into the arid, tropical belt. Its interior begins to dry out. Its unique fauna, the marsupials that had evolved in isolation on Gondwana, are now carried on a raft of aridity, destined to become the bizarre and wonderful creatures of the outback. The sound of Australia's journey is one of drying winds and shifting sands, a gradually intensifying whisper of desiccation. And what of the world left behind? The Tethys Ocean, the great east-west seaway that once separated Gondwana from Laurasia, is being steadily obliterated. As Africa and India move north, they squeeze it shut like a giant vice. The Tethys's final remnants today are the Mediterranean, Black, and Caspian seas. Its death is a slow drowning of an ocean basin, its floor subducted, its waters evaporated and displaced. The sound is a great, geologic slurp and sigh, the subduction of oceanic crust, the last gasps of a vanishing sea. Through all this, the Atlantic Ocean continues to widen at the mid-Atlantic ridge, adding new seafloor like a growing scar. The Pacific Ocean, conversely, is shrinking, its oceanic crust diving beneath the continents that ring it in the ring of fire. The planet is a dynamic, breathing entity. One ocean grows, another shrinks. One continent collides, another rifts. The soundscape of this middle chapter is one of simultaneous creation and destruction. The roar of the Himalayas being built, the sigh of the Atlantic widening, the crunch of the Tethys closing, the crack of Africa splitting. It is a planet in a state of beautiful, chaotic flux. The drifting giants are not just moving. They are actively sculpting the climate, the geography, and the very habitability of the Earth with their immense, slow-motion journeys. And as they sculpt, they set the stage for the final act of our planetary story, the future. For the dance of the continents is a cycle. The scattering will one day end, and the gathering will begin anew. The journeys of our drifting giants are nearing their present-day positions. India is embedded in Asia. The Himalayas a permanent monument to its voyage. The Atlantic is a mature ocean. Its mid-Atlantic ridge is steady, linear volcano. Antarctica sits in frozen isolation at the pole. Africa is still rifting, a continent in the act of becoming two. But as we survey this world, our world, we must recognize that this is not an endpoint. It is merely a snapshot in a film that has been running for 4 billion years and will run for billions more. The drifting never stops. The plates, driven by the mantle's convection, are in perpetual motion. So, let us project this motion forward. Let us complete the cycle we began with Pangaea's birth. The continents, having scattered, will one day reconverge. Geologists, using computer models based on the current directions and speeds of plate movements, can sketch the map of the distant future. In perhaps 250 million years, the Atlantic Ocean may stop widening and begin to close. The Americas, driven by subduction zones on their western coasts, could be pushed back toward Europe and Africa. Australia, continuing north, will collide with Southeast Asia. Africa, having fully split along the East African Rift, will see its Somali plate sail eastward. All these movements point toward a new supercontinent coalescing in the tropical realm, a future assembly sometimes called Amasia or Pangaea Proxima. This future supercontinent will be different from its predecessor. It will likely form in the equatorial region, leaving a vast global ocean, the new Pacific or the Superatlantic, covering the rest of the planet. Its formation will radically alter global climate patterns, ocean circulation, and sea level. It will be a world of extremes, perhaps with a massive, inland desert at its heart and shallow, warm seas on its fringes. The cycle of supercontinent assembly and breakup, the Wilson cycle, will have turned once more. Hearing this, you might perceive a deep, comforting rhythm in the Earth's history. Birth, scattering, and regathering. It is the planet's long, slow breath. That deep, cyclical pulse in the soundscape is exactly that. The tectonic pulse, the pulse of mantle convection that drives the plates, the pulse of supercontinent cycles that last 500 to 600 million years. It is a rhythm so slow it makes human history seem like a single, fleeting note. This perspective is the final, humbling gift of the drifting giants. They teach us that our world, with its familiar continents and oceans, is transient. The map is not fixed. The ground beneath our feet is part of a giant, rocky raft on a journey with a destination set hundreds of millions of years in the future. The Himalayas will one day be worn down to nubs. The Atlantic may close. Africa will split. Nothing in geology is permanent except change itself. Yet, within this grand, impersonal cycle, there is a poignant beauty to our present moment. We live in the age of continental diaspora, a time of magnificent geographical diversity, of isolated ecosystems evolving in wondrous ways, of ocean currents that moderate climate and support abundant life. It is a golden age of biogeographic variety, made possible by the scattered continents. We are living in the interesting middle chapter of the Earth story, between the monolithic unity of Pangaea and the future unity of Amasia. As we conclude our journey with the drifting giants, let the soundscape guide you to a place of deep temporal peace. The patient, tectonic pulse is the bedrock. Over it, we can hear the gentle, faded echoes of all the journeys, the lonely creak of Antarctica, the rushing flight of India, the grinding collision that built the roof of the world. They are all contained within that pulse, like stories within a heartbeat. The earth is dancing. It has been dancing for eons. The continents are its partners in a slow, graceful, and inevitable waltz across the globe. We are but brief spectators, granted the vision to see a few steps of this dance. And in seeing it, we understand our home not as a static stage, but as a living, moving, breathing participant in the cosmos. Our story of Pangaea and the drifting continents now draws to a close. But the dance itself, the dance goes on. We have journeyed from the fiery embrace of Pangaea's birth, through its lush and arid prime, felt its heart tear apart, and witnessed the epic odysseys of its scattered children. We arrive now at the final movement of our symphony of stone, the return. The continents, having wandered the globe for hundreds of millions of years, are not moving randomly. They are caught in a grand, celestial pattern, a cycle that turns with the slowness of geology itself. Tonight, we cast our gaze not into the past, but into the deep future. We witness the dawn of a new supercontinent, Pangaea Proxima. To see this future, we must first understand the forces that guide it. The same mantle convection currents that broke Pangaea apart are still flowing, an eternal engine beneath our feet. Today, the Atlantic Ocean is widening, and the Pacific is shrinking. But this will not always be so. Tectonic models suggest the subduction zone, a place where oceanic plate dives into the mantle, may eventually form along the eastern coasts of the Americas. When this happens, the Atlantic's growth will slow, halt, and then reverse. Imagine 100 million years from now, the once youthful Atlantic begins to age. Its oldest, coldest, and densest oceanic crust, off the coast of Europe and Africa, starts to sink back into the mantle. A new subduction zone is born. The Atlantic Ocean begins to close. Now follow the paths. The Americas, driven westward by the spreading Atlantic ridge for eons, will now be pulled eastward by this new subduction. They will begin a long, slow journey back toward Europe and Africa. Meanwhile, Africa, continuing its northward drift, will have fully collided with Europe, closing the Mediterranean Sea entirely and raising a new, mighty mountain range, the Mediterranean Mountains, in a final tectonic embrace. Australia will have long since collided with Southeast Asia, becoming part of a greater Asian landmass. Antarctica may remain isolated at the South Pole, or it may be drawn northward by changing plate dynamics. All these movements point toward a grand rendezvous in the tropical equatorial region. In roughly 250 million years, the continents are projected to coalesce into a new, single landmass. This is not a precise prediction. It is a projection of current motions, a glimpse of the most likely path on the grand tectonic map. Scientists call this future assembly Pangaea Proxima, the next Pangaea, or sometimes Amasia, implying the convergence of Asia and the Americas. What will this world look like? Picture a vast, C-shaped supercontinent straddling the equator, much like its predecessor. A new global ocean, let's call it the Novo Pacific, will surround it. The interior of this landmass, far from the moderating influence of the sea, will likely be a place of extreme climate, a mega-monsoon system with a vast, hyper-arid desert at its heart, larger than any in Earth's history. Mountain ranges, forged in the collisions that assembled it, will snake across its surface, their peaks still young and sharp. But this is not merely a repetition of the past. Pangaea Proxima will be a different entity. Its constituent continents carry the scars and stories of their long journeys. The Himalayas will have been worn down to gentle hills. The Atlantic's mid-ocean ridge will be a fossilized seam, buried under new mountains. The unique life forms that evolved in isolation on the separate continents will be thrown together in a new, great evolutionary melting pot, leading to a burst of new species or a wave of catastrophic extinctions. As we begin to envision this world, let the soundscape build. That ascending, crystalline tone represents the converging paths of the continents. It is joined by a deep, gathering rumble, the sound of future collisions, still millions of years away, but now inevitable. Beneath it all, the steady, tectonic pulse continues, unchanged, the true conductor of this slow-motion ballet. We are listening to the future taking shape, a future of reunification, a future where the scattered family comes home. The assembly of Pangaea Proxima is not an event, it is an epic. As we move deeper into this future age, let us walk the imagined landscapes of this new old world and listen to its emerging voice. The first and most profound change is geographic claustrophobia. With all major landmasses merged, the coastline of the world becomes stunningly simple. One side faces the vast Novo Pacific Ocean, the other may border a shrinking remnant sea. The interior is farther from the ocean than any point on Earth today. This creates a climate of staggering extremes, the supercontinental climate. At the heart of Pangaea Proxima, a desert forms that makes the Sahara look like a garden. This is the mega-desert, with no moisture source for thousands of kilometers. Rain is a rare, violent visitor. The dominant sound here is the deep, constant wind, a dry, roaring river of air flowing from the high-pressure desert interior to the low-pressure coasts. It carries a fine, red dust that settles on everything, a mineral snow from the bones of the continent. At night, with no cloud cover, temperatures plummet, and the rocks contract with sharp, percussive pings, like a geothermal piano playing to the stars. Yet, on the windward sides of the great mountain ranges that suture the continents together, where moist air is forced to rise, there will be super rainforests. These are not the carboniferous jungles of old, but forests of whatever trees have evolved to dominate in that distant age, perhaps towering, silvery forms with leaves designed to capture moisture from the fog. The sound here is a dense, pressurized silence, broken by the drip of condensation and the deep, infrequent calls of creatures adapted to a world of limited space and intense competition. Between these extremes, in the broad, shallow seas that form in the sinking basins between colliding continents, a new epicontinental sea may briefly flourish. Warm, saline, and teeming with life that has survived the great convergence, its waves lap against shores that are the welded seams of former worlds. The sound here is the gentle, rhythmic slosh of a sea that knows it is temporary, that it will be uplifted and drained as the mountains continue to rise. And what of life? The formation of Pangaea Proxima will be the greatest biogeographic event since the original Pangaea broke apart. Species that evolved in isolation for hundreds of millions of years, the descendants of North American and European flora and fauna, the unique lineages of Africa and Asia, are suddenly neighbors. This leads to a colossal evolutionary arms race. Some species will go extinct, outcompete. Others will hybridize and radiate into new forms. The sound of this biological revolution is not one we can hear directly, but we can imagine it as a cacophony of new calls, new rustlings, new struggles layered over the ancient geological sounds, a biotic symphony atop the bedrock melody. Beneath it all, the tectonic engine purrs. The collisions that build the new supercontinent's mountains also trigger widespread volcanism. Volcanic arcs snake along the subduction zones, where ocean floor dives beneath the new landmass. Their eruptions are not catastrophic singularities, but a constant, background process, a deep, subterranean furnace rumble and the occasional, distant boom of a major event, their ash plumes shading the sky and further influencing the extreme climate. We are witnessing a world achieving a new, terrifying, and magnificent equilibrium. It is a world of superlatives, the deepest deserts, the tallest mountains, new ones, risen from the collisions, the most extreme temperature swings. It is a world that is, in many ways, a test of resilience for the biosphere. Yet, it is also a world of profound unity. A single, massive ecosystem stretches from one pole to the other, interconnected in ways impossible in our age of scattered continents. This unity, however, contains the same fatal flaw as the last one, the insulating effect. All that continental crust concentrated in one area will again trap the Earth's internal heat. The mantle beneath Pangaea Proxima will begin to warm, to swell. Superplumes will gather. The cycle's end is written in its beginning. But that end is hundreds of millions of years beyond even this future. For now, in the long, stable afternoon of Pangaea Proxima, the world is whole again. The great dance has completed a full turn. The scattered have returned. The map has been redrawn into a beautiful, brutal simplicity. As we stand on the mental shores of Pangaea Proxima, looking out across its unified immensity, we must draw our gaze back, not just to the present, but to the scale of time itself. The story of Pangaea, its rupture, the wandering of its fragments, and their eventual return, is more than a geological tale. It is a meditation on the nature of change, cycles, and belonging on a planetary scale. The Earth operates on rhythms that defy human intuition. The Wilson cycle, the repeated assembly and breakup of supercontinents over 500 to 600 million years, is one of these grand rhythms. It is a heartbeat measured in eras, a breath taken by the planet itself. Pangaea was not the first supercontinent. It was preceded by Rodinia, and before that, others lost to deep time. Pangaea Proxima will not be the last. This cycle is as fundamental to Earth's character as the water cycle or the rock cycle. It is the continent cycle. Understanding this cycle bestows a profound sense of perspective. All human history, our empires, our art, our loves and wars, has unfolded in a mere geological instant, a single, quiet beat in this slow, tectonic pulse. The ground we consider so permanent is emotion. The maps we memorize are temporary. This is not a cause for despair, but for awe and humility. We are fleeting inhabitants of a stage that is itself dancing to a music we can scarcely hear. This perspective also reframes our relationship with the planet. The great environmental changes we fear, climate shifts, extinctions, are, on this scale, part of Earth's normal repertoire. The planet has seen hotter, colder, more arid, and more unified states. This does not absolve our responsibility for the rapid changes we cause today. If anything, it heightens it. We are not just changing a static environment. We are intervening in a dynamic, sensitive, and ancient system with a momentum of its own. We must learn to harmonize with its rhythms, not brute force against them, but beyond lessons in humility and responsibility. The story of the continents offers a deep, almost spiritual comfort. It speaks of an inherent order beneath the chaos, a pattern, a return. No matter how far the continents drift, the forces of mantle convection will eventually draw them back together. Scattering is followed by gathering. Division is followed by unity. This is a story of cosmic reunion. It suggests that even on the scale of planets, there is a tendency toward wholeness, a gravitational pull, both literal and metaphorical, toward connection. As our journey through deep time concludes, let the final soundscape wash over you. That warm, resonant, fulfilling tone is the sound of the cycle complete. The crystalline note of convergence has dissolved into the peace of achievement. The tectonic pulse continues, steady and eternal, the engine of past and future. We have traveled from a world of one to a world of many, and back to a world of one again. We have seen mountains rise and wear down, oceans open and close, life adapt and radiate. We have listened to the groans of creation, the sighs of separation, and the whispers of reunion. Now, as we return to our present moment, to our world of beautiful, scattered continents and branching life, carry this knowledge with you. Feel the ancient stability of the craton beneath you, but know it is moving. Look at the ocean and know it is both a barrier and a temporary feature. See the mountain range and know it is both eternal and fleeting. You live on a drifting giant. You are part of the dance. The story of Pangaea is our story. It is the story of home, a home that is never still, always changing, yet forever bound by the invisible threads of gravity, heat, and deep, deep time. Good night.